Hello friends, I welcome you all to this session on graph theory. So today we'll be learning about tournaments. So if you look this particular graph, this is basically a digraph. What is a digraph? Digraphs are also called as directed graphs. So here the edges are what we call as arcs because they are having directions. So if I want to go from A to B, then what I can do is I have to follow this particular path. Whereas if I want to come from B to A, I cannot come from this path. So that's why they are directed graph. Directed in a sense, one direction is possible, other direction is not possible. So these graphs are what we call as directed graphs or digraphs. They are represented by capital D. Now, in case of directed graphs, basically when it comes to the degree of vertex, you all know that basically three types of degrees are evaluated, that is in degree, out degree and total degree. What is in degree? In degree means that how many edges are falling or coming to that particular vertex, and out degree means how many edges are going out or arcs are going out, and total is the total sum. So if we look this particular vertex D, then here this is going out, this is going out, this is also going out, but this is coming in. So what is the in degree for this? So it is 1. What is the out degree for this? It is 2. And what is the total degree? The sum of these, that is 3. So in this way degrees are evaluated for any particular vertex. In digraphs the edges are called as arc. This I have told you. Now let us say I am interested in finding out the in, out and total degree for this particular digraph. So if we look the vertex A, then all the edges are going out, all the arcs are going out. So out degree will be 3, but none is coming in. So that's why this is having 0 in degree. So the total will be 3. Now if you look B, so here this is coming in, this is coming in, and this is going out. So 2 arcs are coming in, so in degree will be 2, and 1 is going out, so out degree will be 1. So here it is 2, 1 and 3. Now when it comes to C, 1, 2, 3, all the arcs are coming into this vertex C. So this is having in degree 3, out degree none is going out, so 0, so total will be 3 only. Now D. So here we have already seen that it is 1 is coming in, rest are going out, so it is 1, 2 and the total is 3. So important thing is, if you note vertex A and vertex C. So here what you can see is that the in degree for vertex A is 0. That means no arc is falling into A. Whereas the out degree for vertex C is 0. That means no arcs or edges are going out from vertex C. So these type of vertices where nothing is coming in, they are called as source. So the vertices for which in degree is 0, they are called as source. Whereas for the vertices or the vertices from which nothing is going out, they are called as sinks. So vertex for which the out degree is 0 is called as sink. Now a graph which is obtained by removing directions of from a digraph is what we call as a underlain graph. So if you look this particular graph, this D, and you remove all the directions, then you will be getting this graph. So this graph G is basically the underlain graph for the directed graph D. Okay, now comes the tournaments. So what are tournaments? A tournament is a digraph where every two vertices are joined by exactly one arc. So here A is joined to B, C and D. B is also joined to A, D and C, and C is also joined to A, D and B. So a question normally can be asked that what is the underlain graph for this tournament? Yes, you are right. The underlain for this will be a complete graph, that is C4. Okay. Now the question again comes, why tournaments are so important? The tournaments are important because they gives us the possible outcomes of a round robin match. Now you will be asking, what is a round robin match? So let us take one example, a round robin fixtures. From there you can understand what exactly a round robin match is. So consider this archery game and three archers are playing, archer 1, archer 2 and 3. Now if every two player in the tournament they are playing a match, then that particular type of tournament is what we call as round robin tournament. Here if you look, that archer 2 is playing with 3, archer 2 is also playing with 1, and archer 3 is playing with 1. So how many players are there? 3. So every player is playing every other player. So that's why this is called as a round robin match. And in case of a round robin match, tournaments, that is, those diagraphs are very important to tell the scores. Okay. Now, in this particular case, archer 1, archer 2, archer 3. Okay. Archer 1 has played 2, archer 1 also played 3. Archer 2 is playing or played one game with 3. Okay. Now, you have to remember that whenever it comes to tournament, no game can stop with a tie. That means all the games should have some outcome. That means either one wins or other lose, or other wins, first one lose. But we will not be having a situation where the game is tie. So here, how to decide that which is winner? So the simple thumb rule is that the winner is the one from which the arc is going out, or from where the arc originates. So if you look the match between A1 and A2, that is this match, then you can see that the arc is going away from A1 towards A2. So A1 is the winner. Similarly, in the match between A1 and A3, who is the winner? A1 is the winner, correct? Because the arc is going out from A1 towards A3. And in a match between A2 and A3, who is the winner? A2 is the winner because arc is going away from A2 towards A3. So now the time comes for this score. So if A1, A2, A3 are there, what is the score of A1? How many matches A1 wins? 2 matches. Okay, so the score is 2. How many by 2? A2, so it is 1. And A3 won how many games? None. A3 loses by every player. So every player has defeated A3. So therefore, the score for A3 is 0. So this is how you can predict the score of any tournament. And here you can see that A1 is at the top. It is the winner of the tournament. Okay. So one observation you can also see here. What is the out degree for A1? It is nothing but 2. What is the out degree for this A2? It is 1. What is the out degree for A3? It is 0. So that is what we are getting as scores, isn't it? So therefore, remember, this is the observation that the score of a player in any tournament is nothing but the out degree of that particular player. That means the vertex, because players are normally represented, or teams are normally represented by vertices. Okay. Now let's take one problem. It says that we are having 5 players, A, B, C, D, and E, and they are playing one tournament which is a round robin tournament. And some conditions are given that A defeated all the players, D was defeated only by A, B was defeated by C, E defeated only 2 players. And what we were expected to find out that are there any 2 players having the same score, or let's say I am also want to predict that what is the score of every player in the match, in the tournament. Now, first what we have to do is we have to draw the vertices. And what will be the vertices? They are nothing but the players. How many players are there? 5. So we have to draw 5 vertices. Okay. Then A defeated all the players. A defeated all the player means we have to draw an arrow from A towards all the players, because you know that if this is the case, then the arrow is originating from X. So X is the winner, Y is the loser. And in the statement, it is said that A defeated all the players. Means arrows will be going away from A towards all the players. So let us say these are the matches. Then what we have to do? We have to draw arrow. Arrow going away from A. That's it. Now comes the second statement. It says that D was defeated only by A. So the player D was defeated only by A. And if you look this particular scenario, the arrow from A to D is already towards D. That means it is coming out of A. So A is already winner. So what we have to do? We have to connect all the remaining vertices with D, and the arrows will now be going away. Why? Because already A defeated D, and remaining D will be defeating. So now the arrows will be going away. That's it. Now B was defeated by C. So there is a match between B and C, and who defeated B? C. Then E defeated only two players. So here if you look, in a match between A and E, E was defeated. In a match between E and D, D defeated E. How many players are remaining? B and C. So these are the players whom E defeated. So this is the match, and E defeated B and E defeated C. So arrows are going away. So now what is this? When I draw the underline of it, it will be nothing but a K5, K complete graph. So the tournament drawing is over. Now I have to find out the scores. Scores for A, B, C, D and E. So now what I have to do, I just have to find out the out degree. So it is 1, 2, 3, 4. So the out degree for this is 4. So the answer is 4. What about B? This is coming in, this is coming in, this is coming in, this is coming in. Oh, all the arrows are coming in. That means everyone defeated player B. So the score is 0. Now see, this is defeated, A defeated C, E defeated C, D defeated C, but C defeated B. So therefore only one match C won. So it is 1. What about D? D was only defeated by A. So from others D won. So D won how many matches? 3. What about E? So out degree is 2. So 2. So in this way you can predict the scores of the tournament. Okay, so if you look this particular, then can you tell who is the winner? Yes, it is obvious that A is the winner. Apart from this, can you tell me that are there any two players having the same scores? No, all are having distinct scores. So there are no players in this tournament who are having the same score. Got it? Very good. Now you should remember that in any tournament the number of wins should be nothing but NC2, that is nn minus 1 by 2, and that is what the sum of the out degrees of vertices in any tournament. Okay, so if I am having a question that in a 7-player tournament the recorded out degree of 6 players are this, and I am interested in finding out the out degree or the win for the 7th player, then what I have to do? I just have to use this formula. That is, the total degree, the total wins in a 7-player tournament, which is a round robin, should be nn minus 1 by 2. Okay, so that is 21. And 6 players have won 5, 4, 3, 3, 2, 1. So what is the win by how many matches does the 7th player win? Let's say it is X. So add them up, and that addition should come out equal to 21. Then you can very easily evaluate what is X. So here if you solve, X will come out as 3. So the 7th player has won how many matches? 3. That is the out degree of vertex 7 is 3. Likewise, you can also solve this. Determine whether the following non-increasing sequence is a valid tournament score sequence for NS6. So 1, 2, 3, 4, 5, 6. 6 players are there. That means 6 vertices are there. These numbers represent what? They represent the scores. Okay, and you all know the total of score of any tournament should be equal to nn minus 1 by 2. And what is n given in the problem? It is 6. So if you solve this, you will be getting 15. Now, if you add the scores, that should also come out as 15. Yes, hence this is possible. So friends, in this way, we can handle problems related to tournaments. And now you know what are tournaments, how to predict the scores of any tournament, and how to solve simple problems. So in this lecture, till this point only. In the next lecture, we will be learning about graph coloring. Thank you very much for watching it.